Okay, this is the 184N kind of a slideshow. Has some diagrams of burners and different things. This is 100N reactor. This was the powerhouse here. Combustion Engineering had two 200,000 pound an hour boilers sat in this building. The forced draft fans sat next to them inside the building. This was the Combustion Engineering stack. Over here was the Foster Wheeler boiler. Here's the Foster Wheeler stack. The forced draft fans for the Foster Wheeler sat outside. You can see these red items here. This was the deaerator for the powerhouse. Over here the reactor sat back in this building. Maintenance shops. The fuels was back here. These were steam vents on the roof in case of a severe pipe rupture. The fog sprays are supposed to knock down the steam and the pressure rapidly. These just release the initial venting if there was any. Back here's the 109N rooftop pipe. That's where all your steam lines were coming out of the steam generators and providing various steam utilities. A bunch of offices, shift supervisor office and stuff sat back here. Over here you had the B-bus breaker room coming off the on-site turbine generator. Say these boilers are only used for startup and shutdown, so they usually didn't run. They're kept warm with steam. This is a drawing of the Foster Wheeler boiler. Had your two decks of burners. Your main gun sat down this tube, and there's a spinner on the end of it. Air register to mix air. You had to have good atomization and good air mixing to get a good burn on it. These boilers were suspended on the bottom. A lot of the main generating boilers that pulverize coal are suspended from the top. Had a steam drum. Had like a bull nose, try and get good mixing of the air and fuel. Keep heat up so you get good combustion, burn all the carbon up in the fuel. Up here's where the flue gas would leave the firebox. It went down the riser tubes. There's some baffles in here trying to get the flue gas to cut across tubes, get maximum heat transfer. Down here it went back over the downcomer tubes. This had several downcomers. And here is the flue gas outlet. This is the diesel igniter. Here was your diesel oil gun. It used diesel and air. I had a spark plug sat back in here. This was the flame scanner. I guess these use ionization for detecting the flame. They had an air cylinder that'd drive them in to start. Then when they weren't running, they'd come back out to keep them out of the heat of the fire. This is one of the burner details. In order to start this, you had to shove this gun in. Went in probably about to here. Had to open both these valves, steam and fuel oil, and then they could be started from the control room. Igniter would go in, light, and then your fuel and steam valves would open. Use the spark plug igniter for the igniter. Just the end view of it. There's a diffuser on the end that just tried to mix air with the fuel better. This gun part slid out. You had a little valve that would close when you pulled the gun out. You'd seal this off because this was a pressurized firebox. It'd keep the gases in the boiler out and also fire from coming out. You had a nut on the end you'd take loose, and then the latch would flip down, and then the gun would slide out. There were two copper crush gaskets. You just had to make sure they went back in, or something's going to get sprayed with oil. This is the Combustion Engineering boiler. I believe it was a D-type boiler. The bottom had refractory in it. The front face was refractory. Around the burners was refractory. These had 3 burners and igniter in the middle. Back here's a viewport. In order to look in this, you had to turn the air on to blow the fire back, otherwise it could throw flames out about 6 feet. Now if you just open the port at full load. These had lines in there to keep them warm. Basically this is the firebox here. The fuel was burned, mixed with the combustion air. They had primary and secondary air mixing, trying to get a good mixture of the atomized black oil and the air to get good combustion. Went down here, turned, then went back, and then the stack was on back here. Forced draft fan sat on the ground floor on the other side. Had the steam drum. These had soot blowers in them. It was very rare to blow soot because they didn't really run that much. But the big thing, looking in a pressurized boiler, you will get fire come out at you. So you had to use air to blow it back. Kind of an inductor that would allow you to open up the port and look in. But the panel behind there was kind of burned from people opening up the viewport at high loads. Had a forced draft fan on the combustion engineering. Here's the burner throat. Had a damper, a wind box, steam drum was on top. Water drum, mud drum was on the bottom. That's one of the combustion engineering igniters. Basically used air and diesel. You had a igniter air inlet that would blow through here to cool it and provide air for the burning. These little spark plug in here to ignite it. High voltage spark transformer on the outside. That's one of the guns on this. You'd loosen the clamp screw. First you made sure it was valved out. This would drop down. Then you could pull the gun back. These were really hot when they come out of the boiler. Easy when you're running, you had to change them. This nut on the end, you'd unscrew it. Then there's a little plate inside your nozzle plate that come off. And then there's the mixing plate right back here that mixed the steam and the oil up. This provided the atomization back here. This part here provided the spray pattern to get a good mix with the fuel, steam mix, and the air to burn. These would coke up real bad. So I believe every 12 hours we were cleaning guns. Depends on the fuel and the additives and how hot they're running, but it was a job to clean these. Every shift you had to clean guns when you're running. But you had a nozzle piece that sat here, and this nut secured it. You can kind of see the nozzle, the nut here. Nozzle piece sat here. Mixing plate sat here. Had holes drilled in it to mix the steam and the oil to break it up into very, very fine oil droplets, and it was sprayed out. They had a spinner plate. Try and mix the oil droplets with the air to get a good combustion. This is the CE combustion engineering. You had one igniter in the middle, and then there's 3 oil guns around the outside. Your main flame scanner. This is refractory furnace. Primary air inlet and the secondary air inlet and spinner vanes. The big thing is trying to get stage combustion. Now if your flame temperature got too hot, I believe it was around 2000, 2200 degrees, you're starting to get a lot of NOx formation. So if you can spread out the combustion and keep your combustion temperature down below that, it minimizes NOx formation. This oil was kind of dirty. Like I said, it had some water in it, and a little sulfur, and a lot of whatever's left from the crude oil refining. I think it was 1 grade above asphalt. Here's the front face of the combustion engineering. You had your secondary vanes. You had your 3 burners and igniter in the middle. Basically had your igniter probe, your scanner probes. That's just a little package boiler. And that's the end of the 184N powerhouse. Probably our next video is going to be on starting on the steam systems. But that's what Reactor looked like back in the glory days when it was running. This was probably on a weekend when it was shot because there's no cars in the upper parking lot. And that concludes this video.